So we're talking about soil science today, and y'all are ready, right? Probably should have started with this last week, start from the ground up, Yeah, one of our speakers later in the session, he has a lot of these corny jokes, so I'm not that great at it. Normally people laugh at me when I'm not trying to be funny, so let's see. There's the clicker. All right. So I like this picture here, the soil and the sky. Looks beautiful. I should have substituted for one I took earlier this year. If you take Wilmouth Road towards this direction, some of our cornfields and wheat fields they're growing houses now. And I took this one photo, it looked like the houses were just coming right out of the soil. And a lot of people do say we're just growing houses here in Collin County, and a lot of people don't even realize we do have a lot of agriculture, and sadly, some people think that's going away. I hope that isn't the case. I know that a lot of our large acreage farmers and ranchers have been selling off over the decades to developers. And probably a lot of our farmland is actually owned by developers, but the farmers continue to lease back that property and produce crops on it. So let's just start off with where soil comes from, and I'll put some local knowledge into some of this as well. So where does it come from? Well, I like the Grand Canyon, and this is a profound picture. It comes from rocks, and a good example of rocks and erosion creating soil is the Grand Canyon. And so what is soil? It's produced when a geologic material is acted upon over time by climate and biological activity. It's a primary source of water and nutrients for plants. It's a physical anchor for plants to stand upright. It allows for healthy and productive plants. So soil is the mineral component. When we identify soil, we look at the mineral component. And primarily we refer to the soil. It's made up of, it's a complex ecosystem that people don't really realize, and we're still learning more and more about it. And it is a very important resource. Again, these are on the Dropbox that you can access. So rocks become sediment and soil. And so these are all the different geological rocks and forces acted upon to create soil. And on the next week's quiz, you'll have to recreate that. That's a joke, obviously. This is just to show you that there's lots of things going on. So and the point of this initial part is just to kind of open your eyes to soil, and hopefully you have a better appreciation for it. And this is something to appreciate conserving our soil. This just shows the number of years involved in creating soil. So we're looking at 1,000 to 100,000 years to create soil. And so a local issue is when developers come in to this previous farmland who had great topsoil, and then they scrape all that off. Well, where does that go? Are they conserving it? Who knows? Maybe it's fill dirt at another site. That topsoil is a valuable resource, and The earth only has a certain amount of it. And when we remove it and don't conserve it, or we allow erosion to occur, which is a major issue in farming, when we allow that to erode or blow away, and all the other forces that are acted upon the soil, we lose it, and it ends up potentially in Lake Lavon. There's a lot of soil that ends up in Lake Lavon, and that's a sad thing. Those of us who have gained an appreciation of soil, when they see it just ending up filling up the lake and then reducing the amount of water that could be stored, that it just makes you sick, because you know how valuable that is. And there was a friend of a friend who lives over by a creek north of the lake, and he called me up and said, "Can you come out and look at my creek?" So I did, and he said, "I used to be able to drive across this little creek, but now it's this big canyon because they had increased the stormwater flow because they built houses north of the creek and increased the amount of water flowing down that creek, and it just eroded the whole thing. And there's this big, I say canyon, but it's 100-foot wide, probably 40 feet deep thing now. It used to be a little low spot. And so I called up people within government agencies and said, "What can we do about this?" And they basically said nothing, which is sad. And just to tell you what the bottom line was, is that particular community he lived in, they're under a certain population level, so then they don't have to adhere to any stormwater management regulations. And so that's a real sad thing. So stormwater management is by the state is based on population size of the community, and so common sense doesn't come into play, I guess. So that's just a little. I get on soapboxes, but unless I think it's good because these are issues that are facing our communities, and we need to be proactive about it. I will say that a lot of the larger cities that have the higher population, they adhere to those rules, and it does make a difference. Yes?
How many inches of topsoil do you generally, as an average around this area, do you have?
That's a good question. I don't know the answer. This is a thing I'll talk about a little later, but this is the Collin County Soil Survey that was released in 1969.
Oh, up to date, in other words.
You're not up to date. But that's a good point. Is it's not up to date because things have changed. Our farmland that hasn't been really touched, that's pretty much the same. I'll show a picture of the survey for the park and stuff and go through that. But so what type of soil do I have? That's a common question. Well, this is just a overview, we have a lot more different soils than this, and if you look at this survey, you realize this is a generalized map, but that's pretty impressive as it is. We're in the Blackland Prairie, which runs from up here all the way down to San Antonio, and it consists mostly of the same type of soil. I think that's a cool image of Texas. I pulled that off the internet. So if you want to find it, you can do the same. But if we want to determine what type of soil we have, this is a method of doing it. So if you send in a sample to a testing lab, they will separate out the 3 mineral components of soil, separating into clay, silt, and sand. And then depending what percentage you have of each of those, it'll fall somewhere within this triangle, and then that's kind of the general classification. Now there's this whole other thing of soil taxonomy, which gets more complicated. And this is the relative size of the different soil particles. Gravel is not really soil. You may have gravel in your soil. A lot of times around here we call it caliche. You may have heard that term where you have this real rocky soil. But sand, silt, and clay, so you might not realize sand is a very large particle compared to silt and clay. And so this is referred to soil texture. And soil texture, these are descriptions of the soil if you're trying to identify it just visually and by touching and feeling it, and trying to make, like in the clay loam, forms short ribbons of less than 3 centimeters long. And so then we get into soil taxonomy, and so Collin County has Houston Black Series, or Houston Black Clay as we refer to it. And Houston Black Clay is actually the state soil of Texas. Yeah, so just like the pecan trees are our state tree, the mockingbird is the state bird, the bluebonnet's the state flower. We have the state soil too, and it's the Houston Black Clay, and it's specific to Texas. So it is a vertisol, which is a type of soil, and it has smectite. And smectite is what's responsible for the swelling and contracting of the soil, whether it's wet or dry. And I think we're all familiar with the massive cracks that occur in our soil. Yes?
I'm confused about clay, because I always thought clay was like a light color, but our clay is so black. What
Yes.
makes it so black?
That's just the mineral component is a real dark color. That's just, yeah, so the rocks that it's made from that eroded many hundreds of thousands of years ago was the dark color, so. Let's see, Houston Black occurs in Black Country Prairie, as I mentioned, from Bonham all the way south to San Antonio. So generally, if someone calls the office and asks about their soil or talks about it, they're going to have the same type of soil, this Houston Black Clay, or they're going to have something similar to it. Now, if that land's been developed and they remove the topsoil like I referred to, then they're going to have some type of clay that's worse. So some of you may have that, and I feel sorry for you. Will it support plant growth? Yes, but it's going to be a lot harder. It's going to be hard to maintain nutrient levels in that soil. And it's not going to have any nutrients to begin with.
Can I ask you?
Yes.
Somebody, when I told them how disgusting our soil was, they told me that it actually has a lot of minerals, that the plants just can't get it out of the clay.
Yeah, we'll get into that a little bit, and that has to do with pH levels.
Okay,
And, yep.
but is that true? I mean, is the
Yeah,
soil?
yeah. So it is a good soil. Our soil is good. It's nutrient rich, and mostly you just have to add nitrogen to the soil, and it has plenty of the other nutrients. But like you mentioned, it can be hard for the plant to take those nutrients out of the soil, and it has to do with pH, and we'll get into that in a little bit. So here's a Collin County soil map, and that's directly from this book. They actually have after a while they upgraded to having a CD of the book. And then eventually they upgraded to having a website. So there's no need for this book anymore, but I thought I'd bring it for nostalgia's sake. And you can see that it's got these little maps, black and white, and you can pull them out like that. So you can see that our creeks and rivers and lakes have some impact on the type of soil. So this is 1969. This is Myers Park and Event Center right here with the red line around it. And we are right here. So our perennial garden is right up here on the corner here. And when we look at this, we look for whatever falls within basically kind of like a topo map. So this is AUC2, and then right in here it says, I guess it's AUD2 or LEB. And then we have HOB, so our part of our shrub garden and crepe myrtles, and then our vegetable garden is in this HOB. And so you're like, what does all that mean? Well, I guess I forgot to put it on there. Let's see. There is a legend that tells you what those things mean. So here's the legend. There should be another slide of that. I apologize, but so if we look at HOB is Houston black clay, and then we look at, what was the other one? AU. That's Austin silty clay. The LEB is a Louisville silty clay, and so they're basically all clays. It's just they're naming it after different towns and stuff. So I don't know that I could tell the difference between it. And likely it's based on texture analysis. You can also see on this map that the elevation topography makes a difference too. We also, part of this is the legend talks about percent slope too. So when we look at number 2 there, it refers to 3 to 5% slope. Actually, no, that's wrong. The C and the D refer to slope. So when we look at C or B or D, it's talking about the level of slope. And you look out the window here and you can see that, yeah, right in there, it's a steeper slope. And what's important about that? Well, that's relative to erosion. So let's see if this will do it. So this is a little video of me showing you how to use the website. So this is the Web Soil Survey. And so here I'm typing in the address of Myers Park and Event Center. And then I click View. So then it shows me the address here. I use the little hand tool to kind of change the area there. This website can be tricky to use. This is why I put together the little video. But then we click on Area of Interest, or AOI, and then we want to set that. So then we click on the AOI tool, and then we select that area that we're interested in. That might be your neighborhood or your home. And then therefore it's selected, and then we click on the tab at the top for soil map, and basically it shows the soil map with the satellite image overlaid. And then we can look at the legend of that. So then it shows you There's a Altoga silty clay, Austin silty clay, Houston black clay. And then it gives you more details about that, whatever's within the mapped area. Does that make sense? Yes.
What is the website?
It's Web Soil Survey. Just Google search Web Soil Survey.
Thanks.
And then, so if we go back to the beginning here, that's what it'll look like, and using two different computers here. So you click on this green button here, and then it takes you to this portion. For most of y'all living in a neighborhood, this is not going to be that important because the developer probably has changed your soil. I'm fairly lucky in my neighborhood because I have a very deep Houston black clay, and I've dug down several feet deep, and it's all very consistent. So I have a good deep topsoil. Some of you may dig and then it changes, the profile of the soil changes. And so we'll talk about soil profiles here in a minute, but so there's what you end up with. And soil profile. So this is similar to what I have in my house, where I've dug down several feet and it's all very consistent. But in many of our neighborhoods, we may dig down a little bit and then we start hitting like a white clay. Or if you're very unlucky, hit a yellow clay. So it typically is black, white, yellow. And so the yellow clay is the white and the yellow tend to be not nutrient rich, not have a lot of nutrients already in it. It's not a true topsoil. And so, but this is just to show you, some of you may be real unlucky and have a lot of rocks. So you have a very shallow soil. This is a sand, and you might have different colors of sand. I'm sure there's nobody in here who has a true sand. Now our developers or builders will put in sand as a fill dirt around the house. And that's actually a good thing if they can put a pretty good layer of sand around the foundation, because it's not going to move around as much as our black clay will. So just talking about developers, just a typical construction site. They're not too concerned about the soil at all when they're building our houses. As gardeners, we should be really concerned about it and what they're using and what they're doing to it. So what do you need to know about your soil? Well, here's different soil properties. We look at physical, chemical, and biological properties. And within each of these, there's different properties that we can test for or try to improve. So our physical would be, aggregation, the actual structure, surface sealing compaction, porosity, water movement, and availability. Chemical would be more pH, salt content, sodium, nutrient holding capacity, and nutrient availability. And then we also have a biological component, which includes all the different organisms, root systems, organic matter in the soil. Yes?
So last week you said not to put topsoil down, but this week you're saying topsoil is really important.
Well, that's two different things. So when I was talking about topsoil, I was referring to if you go to the store and buy topsoil, that's not going to be our topsoil that's here. That's going to be a topsoil that came from somewhere else. So that's what I meant And it's okay to put topsoil down, but realize that that topsoil is not the same topsoil we naturally have here. That's just to clarify what I was mentioning last week. So if we want to improve our soil, we want to add compost, and I'll get into that. Now, if you don't have a good soil, like you have the white clays and yellow clays and rocky soil, then yeah, putting topsoil down is a good idea. Now, whether you go buy that topsoil in a bag and use that is kind of a more of a tricky question, because what I recommend is using our native soils as a topsoil, because it's going to blend well with what you already have. Now, if you go in with the sand and clays don't really mix well. So
There's no, place you can buy native topsoil?
most people don't sell native topsoil in a bag, because most people don't want our native topsoil. You are able to get it. You just have to go to a special place to get it. So.
And you can get it in
My
bags.
backyard.
No, I don't think you can get it in bags.
Because if you know, when I lived in the country, we'd get a truckload of sandy loam or whatever they would. put
Yeah,
in.
I think if
But
you
here,
want a
now
native,
I'm in a neighborhood you couldn't do.
if you want a native clay, you have to buy it in bulk. Yeah. Yeah, I know Soil Building Systems in Dallas will do that. They'll actually create a mix, because they've done it for me. So you create a mix with native soil and compost. And that's the only place I've been able to find that will do a native soil mix. So it's called Soil Building Systems. It's a commercial company. They do compost, expanded shale, all sorts of things.
You can build your own with a nice big tarp and just flag down one of your neighbors and put in a pool.
Definitely. Yeah.
They love dumping that dirt somewhere.
Well, I've seen places that just have a sign out by their yard that says, looking for native, fill dirt, native clay fill dirt or something. So there's a lot of farmers putting in ponds and stuff, and they may end up with some extra soil too. Okay, so let's talk more about soil properties. So texture would be that sand, silt, and clay. pH is, whether it's acid, neutral, or alkaline. So the lower the number on a pH scale is more acidic. And then 7 is the middle, and that's neutral. And then, so it's a 0 to 14 scale. And then 14 would be alkaline, or the higher number, above 7. Fertility would be all our different nutrients, nitrogen, phosphorus, potassium, and all the other nutrients. And then organic matter would be just a percentage of that within the soil. And then drainage would be water infiltration rates, water holding capacities. So this would be the soil texture. And if you're very interested in it, you can do a texture analysis, and you can request that with a soil test. It'll place it somewhere within this triangle. Yeah. Around here, typically, it's not necessary. You just know that you have a clay. You hope for the red one. Is that what? Yeah, more than likely, it's going to be this blue or down in here in the silty clay right here. Most people want a sandy loam. So we don't have that here. Now you could create a raised bed or box that you put that in, if you wanted it. So then here's another image of the different soil particles, just to give you an idea. You can see a little tiny dot, that's clay. And then soil structure, these are different terms used to refer to the structure of soil. Yeah, platy. And we generally have this granular. And then, so if we look at a soil, this is kind of, it just shows the different mineral components that you might have in it. And then you have air, you have organic matter, you have water. You also have microorganisms in there. And then if we look for an ideal soil, we want 50% solid materials. So it'd be soil mineral components, 45%, at least 5% organic matter, and then 25% air, 25% water. So that's pretty significant. And this is going to be the pore spaces within the soil.
They didn't mention that organic, the 5% there in the book.
They didn't mention that?
No.
This is kind of the generalized, what most people say, 5%, but when we talk about gardening, we want a lot more than that.
Yeah.
But this is just general soil science. This is all the pore spaces. So you think of the soil as 50% pore spaces. Well, with the clay, with the particle size so tiny, the pore spaces are really small. Sand is easier to achieve this 50% pore spaces. But that's why a lot of people use rototillers. They till their soil to try to get more air in there so that you can have more air and water in the soil. And so if we look at different levels of water within those particles, we look at saturation as all the pores are filled with water. Field capacity is the available water, is the amount of water in the soil that's available for plant growth. And then the wilting point is no more water is available to plant. So there may be moisture in the soil, but the plants can't extract it. And when we think about drought tolerance in plants, because we do want a lot of drought tolerance, some plants are more able to extract water from the soil. So the ones that are less able get to that wilting point sooner than those that have more drought tolerance. So when we were testing a lot of plants during the drought, there's plants that they look great and without several months of water. And those plants are more able to extract more water from the soil, but they're also more efficient at using the water and probably lose less water to the atmosphere. So who makes those plants?
What makes those plants more drought tolerant?
Root systems, the architecture of the plant, physiology of the plant, genetics obviously control all that. Now a lot of those plants are natives, so they're adapted to the routine droughts that we have here in Texas. That's another good point. So they evolved to withstand these usual. If you've lived in Texas very long, you know we have an annual droughts in July and August. I would say that this year the last 2 years were probably an exception, maybe 3 years. So, but when we were in the droughts, I was always saying, well, we do always have a drought during the summer in Texas, so you just need to be prepared. And I think that's something we really need to think about here, especially during times when we have plenty of rainfall. We need to be thinking about how we're preparing for the next drought, because it's coming. We just don't know when. So you have to always be prepared for it. And as we go through the class, we will be preparing you for it. So if you do what we recommend, you'll be prepared for those droughts. So the relative water holding capacity of different types of soils is different. You can see clay actually has the highest water holding capacity. Sand would be I guess the N is not there, but sand would be the least amount. So if you've ever grown in sand, you realize you have to water a lot more, you have to fertilize a lot more. It has all those large pore spaces, so it can't hold on to the water. So this is another graph showing something similar, but it shows field capacity and wilting point. And so even though clay has a large amount of water holding capacity, not all of it is available to the plant. So it's a little deceiving. So this has to do with the pore space size. And the smaller the pore space, the tighter the water is held within those pore spaces. So sand, you don't have that much available, or it won't hold on to it, and almost all of it's available. And then all these other ones are in between. So this has to do with the effects of capillary action on soil water. So if we have small pore spaces here on the left, that would be like a clay. And then the sand would be over here. This just shows that capillary action has a great effect. And so, are you familiar with capillary action, what that is? So, if you've ever been to like donate blood or I always use that example. So they prick your finger and then they take this little tube and they stick it on your finger and the thing just magically sucks up into that little tube. Have y'all ever seen that? Okay, so that's capillary action. It's the water molecules being pulled into that tube just by capillary action. It's just the water molecules being sucked up in there. And there's no, plunger or anything. It's just capillary action. So the pore spaces within the soil are very similar. So the smaller the pore spaces, the less available that water is to the plant. That's kind of where I'm going with that. Sorry if I'm not explaining it very well. Okay, here's a video. Is there some audio on that, Marv? Or is it plugged in?
It's not plugged in.
Okay.
Plug it in if you want.
Sure, why not? If it's not too big of a hassle.
Let's see how to do this.
Or you can narrate it,
I could narrate it.
If I plug it in, I'm going to have to unplug it.
Okay, don't worry about it, sorry. So this is a video you can see at this YouTube channel. Here we go.
Water can off the land, or often with the help of sound land management practices, water can move into the soil to be an environmental positive rather than a negative. The soil itself has an influence on
Can y'all
whether
hear
water
that?
runs off or moves into the soil. Here's a brief explanation of how and why soils transmit water at different rates, and why you should check a soil survey when you're concerned about runoff, flooding, leaching, or other environmental hazards. Water movement in the soil is strongly influenced by soil particle size, or texture, as well as structure and pore size. Soil texture is the relative amount of sand, silt, and clay-sized soil particles. Sand particles are the largest, silt is intermediate, and clay is the smallest. Water moves more quickly through the large open macropores found in sandy soils than the smaller pores of silt, or the much smaller flat-shaped micropores in dense clay soils. Soil structure also impacts water movement. Water moves more quickly downward in soils with granular structure than a soil with platy structure that forces a longer indirect path downward. Other structures include prismatic and subangular blocking. Water is nearly always moving in the soil, and it can be in any direction simultaneously. Gravity is the dominant force that moves water downward. Restricted soil layers of compacted soil or bedrock are among the reasons water moves laterally. Capillary action, the attraction of water into soil pores, can move water in any direction. Gravity is the primary water-moving force in saturated soils, while capillary actions are the primary forces in unsaturated soils. Capillary force is greatest in soils with small pores. Water moves more slowly through these soils. Well, that's a brief explanation of what a soil scientist calls saturated hydraulic conductivity. In simpler terms, the capacity of a soil to transmit water. Since downward moving water carries nutrients and can carry contaminants into underlying groundwater, soil percolation rates are important in choosing sites for septic fields, landfills, and other waste burials, as well as underground storage tanks and other uses. The information is critical for planning soil drainage, irrigation, and tillage systems, as well as other crop management practices. Get the information you need on water movement rates and other soil properties from the soil survey of your area on the web at www.soils.usda.gov.
Hopefully that helped the explanation. So by the way, we do have a local USDA office. Ed?
I'm sure you're going to cover what happens when you have different soil materials and water stops
Okay.
joined together.
Yeah, I'm sure we'll cover this in the presentation. Just talking about the USDA, since I had a little video from them, we do have a local office. It's called the USDA Service Center. It's right north of our office on McDonald here in McKinney. It's called the USDA Service Center. It has the Natural Resource Conservation Service. Used to be called the Soil Conservation Service, and they're the ones that help put this soil survey out. They have a lot of other functions. There's also the Farm Service Agency that's located at that office too, and we work closely with them on different programming. Another thing that I thought I'd mention is regarding water, since we're talking more about water and erosion and other issues, is that this past year, we do, the water district does sampling of the water at different points within the creeks, within our lakes. And we did have some elevated bacterial levels, E. coli bacteria, within some of our creeks, which makes it considered an impaired waterway, and it can restrict recreational activities. It reduces our water quality. So over this past year, we've been working on developing a watershed protection plan, which was submitted to the EPA for approval through our water district. We have a lot of partners who worked with us this past year with monthly meetings to review the plan and make suggestions. Many of our master gardeners, I know Mary Linda, she was involved in that. Is there anyone else that came to those meetings here? Yeah, Suzanne did too. I did. Yeah, Mary Linda. And so over this next year, or actually in the future, we're going to be having educational programs and other efforts to try to improve people's knowledge about managing our watershed and improving our water quality. And I guess next week we have a program. It's called I think it's called Stream Ecology or something. It's next week at the Herd Museum. I think the program's full, so, but we're going to have other programs coming up this next year, maybe this fall as well, to try to address some of those issues. Let's talk about soil nutrients. So they're important for processes and function within the plants. Growth is restricted by the most limiting nutrient. Yes?
Before we get on too far, where are those classes or courses listed?
Where are those courses listed? Okay. I've been kind of bad about updating my website on some of these. I need to get on top of that, but I do have an email service that I send out emails to. And now that y'all are on the Master Gardener thing, I'll send announcements to y'all as well. So normally I send out emails to announce programs. I also have a Facebook page that I use too. Now, both of my Facebook pages, you don't have to actually sign up for Facebook to see it. You can just go to the website. It'd be facebook.com/Collin County Extension Horticulture. So that's the name of the page. And I post, upcoming events and stuff. Now, if you have like a farm or a ranch, we're interested in horticulture crops. I have a separate mailing list for that. So if y'all want to be a part of that, you can go to the Collin County AgriLife website and sign up for that email list. If you need, it's collin.agrilife.org. And if you just scroll down to the section for horticulture, there's a link that says sign up for the email list. So basic nutrients, carbon, hydrogen, and oxygen. Water and the atmosphere, provide these molecules. So when we talk about soil, it's all these other nutrients or minerals or elements. So the big ones are nitrogen, phosphorus, and potassium. And if we look on a bag of fertilizer and you see those three numbers, that corresponds to these three nutrients. And then we have secondary nutrients, calcium, magnesium, sulfur, and then micronutrients, iron, manganese, zinc, copper, boron, molybdenum, chlorine, and then silicon and cobalt. So this is your bag of fertilizer, and this is the NPK, as they say. And this is the percentage of this nutrients in this bag. So 14% of this bag is nitrogen, 0% in this case is phosphorus or phosphate, and then 26% is potash or potassium. So this is the same here. This is the analysis, guaranteed analysis. And so if someone's to sell fertilizer, they have to have one of these labels on that bag of fertilizer. And we do have a state soil chemist that's officed in College Station on the A&M campus, and he does testing for fertilizer and other things. And so, as you can imagine, if someone didn't have a guaranteed analysis of their product, you wouldn't know what you were getting. And so, for organic fertilizers, that can be a little more tricky, or not tricky. It's just, if someone is creating a fertilizer synthetically, they know what they're trying to achieve. But organic fertilizer is just going to be what's in there, and so it has to be tested in order to for the customer to know what's in there. So we do have a soil, water, and forage testing lab at Texas A&M. It's part of the extension service. It's where you send soil, water, and forage to be tested. And so these are all, the water testing and the soil testing is all related to agriculture, gardening. You wouldn't want to, like if you were concerned about some toxin in your soil, they're not going to test for that. You're going to have to send that to a different lab. And they do have a list of those type of labs on their website that do that type of testing. So if you were trying to figure out how much fertilizer you needed to apply, and you had your soil tested, and they provided you the values of your nitrogen, phosphorus, and potassium in your soil, and they gave me a recommendation, then you need to go out and buy a fertilizer to match that, or it come close to it. You're probably not going to find something that's going to match that. So then you put these numbers in this calculator, all the numbers from your test, what the recommended rates are, and then your analysis of the fertilizer. And then when you use this calculator, it'll tell you the amount of that bagged product to put on your lawn or your garden, and it's per 1,000 square feet. There's lots of fertilizer calculators out there. This is what you kind of call a fertilizer calculator. So if this one doesn't make sense to you, you can always use something else. There's lots of different universities that have different ones. So let's see. Okay. So fertilizer tips, let's just run through these. More is not better. That's something that I'll say about pesticides and other things that we add to our lawns or our gardens. So test the soil and follow the recommendations. If you're fertilizing your lawn, make sure you water it after you fertilize it. So you water that fertilizer in. Why is that? Because if we wait for rain, we don't know how much rain we're going to get. And it could wash that fertilizer away, and then you don't benefit from it, and then it contaminates our waterways. So that's why if we water or irrigate our garden or lawn, we put out just enough to get it to dissolve and go into the soil. If we're fertilizing, we want to clean up all that spilled fertilizer on paved surfaces. That includes both organic and synthetic. When we're working with plants, either our lawn clippings, we want to clean those off paved surfaces because those have nutrients in them too, and when they wash off and go into our waterways, they contaminate it as well. So apply irrigation water judiciously and avoid runoff at all times so that we don't wash off our fertilizer. So when we have erosion occur, that soil also has a fertilizer contained within it, or nutrients, and it can contaminate the waterways as well. Accurately apply your fertilizer to your soil. Excess fertilizer, whether it's synthetic or organic, can be washed away and end up in our waterways and groundwater. And then we recommend use at least 50% slow-release fertilizer, slow-release nitrogen. So this minimizes the leaching of nitrogen into our groundwater, and it's more cost effective because it'll stay around longer and release it slowly to the plant. And 10 years ago when I started this job, it was hard to find a lawn fertilizer that had slow release fertilizer in it. It also was impossible to find a fertilizer. I wouldn't say impossible. It was rare to find a fertilizer that was nitrogen only. But thankfully, I don't know how many years ago, but all the major manufacturers started carrying nitrogen only and fertilizers with significant amounts of slow release nitrogen. So I think that's great. So if we compare organic versus inorganic fertilizers from strictly a fertilizers standpoint, there's no difference because nitrogen and other nutrients can only be taken up by the plant in their certain form. In the case of nitrogen, it's nitrate and ammonia forms. Since organic fertilizers are basically you get what you get, you can't really dictate what's in that fertilizer. A lot of them have high levels of phosphorus, and those can build up in the soil. So we don't want to over apply those organic fertilizers that are too high in phosphorus. Chicken manure is a common one that's used as a fertilizer, and it can have high levels of phosphorus. So over in Arkansas, they have a lot of commercial poultry farms, and they use that chicken manure on the different crops. And they've found that they have to do a lot of soil testing to make sure they don't build up too high phosphorus levels. And that phosphorus was contaminating the rivers and causing a lot of environmental problems. So fortunately, they kind of learned how to better manage the use of that manure. So organic products such as manures can aid in the growth of plants by increasing water holding capacity and aeration, but manures may cause health issues like E. coli contamination. So it's best, always recommend if you're going to use a manure, compost it before you use it. And that allows the microorganisms to break that down. And in many cases, the composting process is going to kill any of those intestinal bacterial that could contaminate us. But if we're using straight manure in our gardens, especially a vegetable garden, you have a high risk of that E. coli contaminating that food product. So over the last 5 years, the federal government's been developing a food safety program, and it's kind of being implemented this year. See if I can remember the acronym. It's produce safety is what we're more concerned with, and they have guidelines that are being put in. So they're essentially regulating more aspects of farming to provide us with a better, safer food product. So really all farmers need to adhere to these regulations. The small farmers, they will be exempt from all the inspections and stuff, but they should still apply. They should still use all these recommended and required practices of keeping our food safe. So synthetic nutrients are highly concentrated, and it's easy to misapply them in excess. It's also if we're fertilizing our yard and we're spreading it out into the street or alley, and we're not cleaning that up afterwards, that's sending a lot of that fertilizer down into our creeks and waterways. both sources of nutrients can pollute the environment when misapplied. So just because it's organic doesn't mean it's safer for the environment. And these next set of slides look at different organic fertilizers, and these are kind of typical analysis for different organic fertilizers. So blood meal is a pretty good one because it's high in nitrogen. So you don't have to memorize these, but these are more for reference. And you can hopefully still find these on the Aggie Horticulture website, or you have access to this presentation as well.
For the next, how many years?
That's a great question. So it was asked, if you didn't hear, just concerned about the potential for contamination down in Houston from all the flooding of sites that are contaminated from,
In the ocean?
yeah, in the ocean. Yeah. Yeah.
Everybody in Texas and perhaps the whole U.S. is ultimately affected by what's going on.
Yes, definitely. Yeah, it's something that it's going to be ongoing to see what happens and see what the impact is. I'm reminded of a few years ago up in near Durango, Colorado. I don't know if you remember that near Silverton, EPA had one of these big ponds full of contaminated mining materials, and one of the EPA contractors accidentally broke down the dam for it and just spilled all into the Animas River and contaminated with toxic heavy metals and stuff. And it turned the whole river like an orange color. So I was up in Colorado just last month, and we were near some of those old mining sites, and yeah, those sites are potentially contaminating our waterways as well. So let's take a break and